Rejoin the session. Just rejoin. If anyone unable to hear me, rejoin the session. Rejoin the session. Yeah. If anyone unable to hear me, just rejoin the session. Yes. So yesterday started basics. So previous classes, all the just introduction, course introduction discussed. Okay, yesterday started actual subject. So before that, all the introductions about course information, what is Java, and all that introduction discussed here. Today, yes, yesterday started actual topic. Okay, yes. So first started with software basics. Started with basics. Yes, introduction to software. So what is software? Yes, software, it's a collection of programs such as C, C++, Java, Python, and all these software programs. Yes, software basically two categories: system software, next application software. System software, it interacts with hardware components. Example, OS. OS is system software. Okay. Yes, application software. Application software. Once again, this guy has to rejoin again. Rejoin. Yes, Mr. Ashish Gupta. Ashish. Rejoin. Rejoin in the session. Yes, leave and rejoin. Yes, again do it. I can do it. Okay. Yes, select audio while joining. Yes, select audio. Select computer audio while joining. Yes, select this also. Select computer audio while joining. So, system software, application software. Application software for the purpose of application development. C, Java, these are other application softwares. Okay, Java is application software. Okay, so before going to this application software, some topic about OS discussed here. Yes, OS. Yeah, it's the second class. Second class, last class, nothing discussed. Mr. Madhu. Last class, all the introductions are discussed. Okay, last class, nothing discussed here. Last class, Mr. Madhu, last class topic. Yes, 8 a.m. topic. 8 a.m. Last class, nothing discussed. Day 1. Yes, about me introduction here. Yes, sir. About course, what is prerequisite to learn Java, course contents, what next after this course. Only these things discussed. So first of all, about my introduction. This introduction explained here. My experience, complete my experience clearly explained here. And next about your course Java, duration 3 months. Yes, sir, time 8 to 9:30 a.m. here. Monday to Saturday classes. Okay. Number of sessions 75 to 79 sessions. Fees only 5,000 here. Yes, 3 demo classes free of cost. Next, certificate from Durgasoft Private Limited. So these things explained last class here. Nothing discussed. Okay. Yes, here recordings, daily recording sharing with you. And the class document, daily class documents. Okay. Yes, your class doc. This is your class document. Class document around 600-page document. 600-page document. This document will be shared with you. This document will be shared with you. It's a class document. Okay, right. This class document with 100 plus interview questions and 200 plus programs. Next, Java 8 and 9 softwares and Eclipse software. These things are sharing with you. So about a course information. Course Java duration 3 months, time 8 to 9:30 a.m. Monday to Saturday classes. The last class discussed. Yes, about prerequisite, nothing required. Non-IT background guys also can understand. Okay. Yes, course contents. See, course contents. First core part of Java. This is for 1 month. Yes, this is completely logic-based programming. 1 month logic-based programming. First 1 month, 100 plus programs discussing completely logic-based programming. Yes, how to improve our skills, improving programming skills, focusing on improving programming skills and logics to expertise in programming. This is for first 1 month. Okay, 1 month. So first 1 month completely, yes, building your confidence in software. So this is for 1 month. Okay, yes, completely logic-based programming. Here we'll be discussing 100 plus programs. Okay, this is last class what we discussed. So next Java oops concept. So first core part of Java 1 month. Yes, oops part 1 month. All the oops features. Next. So once oops features completed, you can get the confidence in Java. Getting confidence in Java. Next, after project development concepts like string buffer, these things, object wrapper classes, exception handling, collections, IO streams, networking, multi-threading, JDBC introduction, and all this. Next, version-wise features. Finally, special focus on Java 8 features. Special focus on Java 8 features. Java 8 interface, functional interface, designer, lambda expressions, method references, Java stream API, collectors, Java option class. Okay, these things. So what next after this course? Okay, yes. Yeah, these things we discussed yesterday, nothing discussed here. See, your complete syllabus, first part 1, just logic-based programming, improving programming skills. Second part, Java oops. Third part, project-related concepts. This is 3 parts, 3 months. First 1 month, second month, third month, that's it. So this is what we discussed last class. And apart from this, introduction given, software introduction given. Yeah, the software introduction. Okay, yes. Let me repeat this also. Software introduction also. Software. It's a collection of programs. So last class I typed all of this and explained. That's the reason taken 1.5 hour class. Everything, all are explained here. Okay, line by line. Every topic I have typed and explained. That's the reason taken for 1.5 hour. Same thing I have saved here. Same thing saved. Okay, saved here. Okay. Yes. Yes. So even this topic also I have typed and explained last class. Okay. Just introduction discussed in last class. See, introduction to software. Just let me review about last class topic here. Introduction to software. Software is a collection of programs such as C, C++, Java, Python, HTML. These are all the softwares. In software, all are programs. Software basically 2 categories. First one, system software. Next, application software. System software interacts with hardware components. Example ways. Okay. Application software for the purpose of application development, applications development like C, C++, Java, and all these are application softwares. Java is a application software. Java is application software. Okay. Yes, before going to application software, something about ways. What is ways here? What is operating system? See, computer, hardware, on top of hardware, OS running, on top of OS, application software working here. So on top of OS, all the application softwares, all the application softwares. On top of OS, all the application softwares working here. Okay, on top of OS, all the application softwares like C, C++, and all this here. Okay, yes, to run programs, OS required here. Can we run any program without OS? No, compulsory OS required. On top of OS, all are running. Application softwares like C, C++, Java, all are running on top of OS. So OS acting like a platform. It's a platform. It's a platform where we can run all the applications. Not only platform, it's an interface. Interface between application software, and hardware components. So this is about OS, what we discussed in last class. Next about application software in this is a front-end software and back-end software. There is a front-end software and back-end software. So front-end, see this is front-end. This is front-end. Here it's a front-end. Okay, here it's a form, some registration form, right? Here it's a registration form. Here it's a registration form. So here it's a registration form. So registration form, this form taking data from users. This form taking data from users and storing into some backend here. So this is called as front end. So front end. So browser. See this form running inside the browser, right? It's a browser. It's a browser. So browser. So browser form details. So this is front end. Front end. Next, this is backend data. Where data storing? It's a backend server. Backend database server. It's a backend. This is actual Java application. Okay, Java comes where here. So where in this complete application architecture, in this application architecture Java, where Java using here? Yes, front end JavaScript as well. Java also using front end. Okay, right? Front end. Okay, Java as the front end and server side programming. Java using as a front end software as well server side programming. Java using at the front end as well server side programming. So this is backend. Okay. So Java is exactly Java front end as a front end. As a front end you can use or server side programming you can use here. Yes. Next. Yes. So front end and server side. Okay. So exactly Java comes where here? Exactly Java comes here. Yes. Front end at the front end using and at the server side. Mostly at the server side. Maximum things are at server side. Server side programming. Java is a server side programming. Okay, right? Yes. Now let us say about front end. See, database, this is not our topic. Our topic is not database. Our topic is this one, this area, this area. Okay. Yes, front end. In front end, there are languages and packages. So package is ready-made one, ready to use. Like MS Office package, ERP packages, Tally accounting, these are all the packages here. Packages. Right? Next, languages. Language, it's a programming completely here. Java is a language. Java comes on languages. See, languages. Okay, languages. Yes, two categories: low level language, high level languages. Low level and high level. Okay. See, software languages basically two categories. Software language, computer understandable languages. Next, user understandable languages. Computer understandable and user understandable. See, computer understandable language that depends on of computers, generation of computers. If there are 5 generations, first generation vacuum, second generation transistors, fourth generation IC, fourth generation processor based, fifth generation AI based. So these topics were discussed in last class. So now present generation is processor based computer. Yes, it's in the form of binary codes. Binary codes. Binary it's system understand. It's a system understandable language. Okay. So finally here, software languages are two categories. Low level language, high level languages. Low level language, it's a system language. It's a system understandable language in the form of binary code. System means a processor. It's a processor understandable language. It is called as machine language. Low level language is a machine language. High level language, yes, it's a user understandable language. It's like a English language. Right? It's very easy to understand. See this. These things. Java, Python, HTML, says all their high level languages. These are high level languages. All their high level language. Yes, C language is a first high level language. C language is a first high level language developed by Dennis Ritchie in the year 1972. Yes, up to this yesterday discussed last class. Just introduction to software given. Just introduction. Just introduction to software. Okay, see here introduction, how introducing into Java. Just observe this, how introducing into Java here. So started with software. Software basically two categories: system software, application software. So Java is application software. That's the reason move to application software. Yes, in application software, front end, back end. So Java comes on the front end, this area, front end area. Okay, so move to front end. In front end, language and packages. Java is language. That's the reason started languages. Yes, in language, low level language, high level language. Low level, high level language. Low level, it's a system understandable language, machine language. High level, user understandable. Java is a high level language. Java comes under high level languages. Java is a high level language. Okay. Yes, up to this is discussed. So last class up to this is discussed. Okay, last class up to this is completed. Up to this topic completed last class. Just only all the introduction discussed. Nothing missing in last class. Just only introduction. Yes, today I'm starting Java concepts. Today starting Java. See here, high level language. High level language to binary code. See, binary code is system understandable language. Binary code means like this zeros ones format. This is binary code. It's a binary code. Zeros ones format. It's a binary code. Zeros ones format. It's a binary code. High level language to binary code. High level language to binary code. See, high level language. See, suppose C program. See, this is high level language. This is high level language. Looking like English language, right? High level language looking like English language. It's a high level language. Suppose some Java program. Java program. Suppose this Java program. Yeah, these are looking like a high level language, right? English language looking like English language. Okay, but system don't have about these languages. Okay, system don't have about high level language. The high level language has to convert into binary code. How? Yes, which one will convert from high level language to binary code? For this, interpreters and compilers. Okay, there are interpreters and compilers. Interpreters and compilers. Interpreters and compilers. Interpreters and compilers. Yes, interpreters and compilers. Interpreters and compilers converts from, yes, high level language to binary code. Okay. Yes, interpreters and compilers. Interpreters and compilers converts from high level language to binary codes. High level language to binary codes. Binary codes. So interpreter and compiler. These two things will convert from high level language to binary codes. Yes, what is interpreter and compiler? Let us see about this. So what is interpreter and compiler? Next, Java. Yes, is it interpreter based or compiler based? The topic we should discuss now. Java, is it compiler based or interpreter based? The topic we should discuss. Now let us say about interpreter and compilers. Topic is about interpreters and compilers. Yes, interpreters and compilers. So what is interpreter and compiler here? This is most important topic. Okay, interpreter. Everyone should have this knowledge here. What is interpreter? What is compiler? Let us say about this. So first of all, let us start with the interpreter. What is interpreter? So what is an interpreter? Okay. For interpreter, see, for this I am taking Python. Python is an example of interpreter based language. So test that Python scripting. Yes, let us see one example in Python scripting. For interpreter, I'm taking Python. For compiler, I'm taking C language. Compiler, C language. Python is a interpreter based language. C language is a compiler based. Okay, let us take some Python code here. Python code. Suppose D drive. Suppose let us take some code. Suppose element of folder. Yes. One second. Delete all these things. Yes, element of folder. This folder is empty. In this folder, just I'm developing some Python script using Notepad. Just using Notepad, simple script I'm developing here. So CMD command prompt. Command prompt. From the command prompt, we should go to D drive mn row. So D colon. Okay. H CLS. Clear the screen. Yes, now we are at D drive. D drive contents. So DER. DER. This shows the contents of D drive. In D drive mn row directory. Here this mn row directory. mn row directory. Now we should go to mn row directory here. Yes, CD mn row. Changed. Okay, CLS clear screen. DR nothing empty. 0 file 0 bytes. Okay, see this mn row. See D drive mn row folder, right? Here D drive mn row. So this is GA, this is character interface. Yes, Windows GA, this is command prompt character interface. So character interface. Okay, now here I'm writing sample script, Python script. Yes, notepad, test.py. Say yes, it will create new file now. Simple script here. Suppose A is equal to 10. Yes, B is equal to 20. So A value 10, B value 20. After that, just I'm adding these two numbers here. A plus B. A plus B. So print here addition, print addition. Addition is equal to yes, C displaying C value. Okay. So addition H next C is equal to A minus B. A minus B. Print subtraction is equal to C value. Next C equal to A into B. Okay, next print. Yes, next multiplication is equal to see displaying C value. This is very simple script. Yes. Now Python interpreter will execute this. Yes, save. So A equal to 10, B equal to 20, C equal to A plus B. So addition. Next C equal to A minus B. Subtraction. C equal to A into multiplication. So program. This script is to yes, perform mathematical operations. Finding addition, subtraction, yes, and multiplication equal to C. Right? So this is simple script. Save and exit. Yes, dir test.py, right? Same thing here also you can see. GA D drive mn row folder in this. That test script is there. Python script. Just a simple script here. Okay, now so what is next step here? CLS clear screen dir. Here they say test.py. This script. See notepad. Yes, notepad test.py. This script. See, this is very simple script. Very simple script, right? Okay, now the script. Yes, next, what is next step? We should run this script here. Python, yes, test.py. Yes, it's working. So what is happening here? Yes, this is Python interpreter. Python interpreter directly executing the script. Python interpreter directly executing the script. Okay, it's not checking for any errors, no compilation process, nothing here, directly executing. Suppose C program, Java program, or C++, all the program, first of all, compilation. This is a compilation process. After compilation, if no errors, then executing rates. But interpret is not like that. So compilation process means checking for errors. So first of all, initially checking for errors. In C programs, checking for errors. In C++, also checking for errors. But in Python here, yes, it won't check for any errors here. Directly program executes. Directly interpreter. Not only Python, any interpreter based language executes the program directly here. It won't check for any errors. It won't check for any errors. Directly executing program. Yes. Then how it's working, how interpreter is working. Let us see how interpreter is working. How interpreter is working. Just let me explain clearly how interpreter is working. Suppose your Python script. First statement. Suppose a equal to 10. Yes, b equal to 20. Just yes, sir. Next c equal to a plus b statement. Yes, print addition. Next c equal to yes a minus b. Yes, print is subtraction. Print is subtraction. Okay, next c equal to a into b. Yes, next print multiplication. Right. So this is your, for example, this Python script test.py. Okay, that statement is just assume that statements here. Now interpreter, Python interpreter, how it's working here. So interpreter, first of all, checking first line, a equal 10. Suppose if it is correct here, simply convert the statement into binary format. Converting the statement to binary format. Okay, the statement a equal 10 converts into binary format, zeros ones format. System understandable language. After converting, yes, it will be given to processor. So processor taking that binary code and executing, generating output. So this first statement. Okay, see, next coming statement may be right or wrong. Interpreter never think about next coming statements. Next coming statements may be right or wrong. Interpreter never thinking about next statements. Suppose if first statement is correct, immediately converts into binary codes and generating outputs. Next, checking for next line. Suppose next line also correct. Next line also correct here. Simply this converts into binary code, same process. Converts into binary codes. Okay. The binary code given to processor. So processor executes that code and generating outputs. So what is happening here? First line checking, then executing. Second line checking, and then executing. So line by line, first line checking, it's correct, then executing. Second line checking, correct, then executing. Okay, it's line by line, Next line, suppose next line, something wrong here. Suppose here this statement, something wrong. At this statement, something wrong. What happens here? At this statement, something wrong. What happens? Stops. Something wrong here, simply stops. Something wrong, simply stops. Here something wrong, stops here. Any error comes, interpreter stops. Yes, it won't check for next statements here. Any error comes, stops. Any error comes, simply stops here. Okay. Yes, if it is correct, then executes. Next one correct, executes. Something wrong, stops. Let me show that. Yes. Notepad, test.py. So first statement, next statement. Suppose here something mistake here, comma missing. Okay. Suppose here some bracket missing. Okay. Suppose here some double quotation missing. Totally there are three mistakes, right? Totally three mistakes. Okay, three mistakes. Right? Now let us run this Python script. So Python test.py. Okay, right? See this. Here, yes, 8th line error, line number 8, 8th line error. Syntax error, invalid syntax, right? Invalid syntax. Actually, there are three errors, but not showing all the errors. First error itself stopped here. In the first error itself stopped. So here only stopped here. Addition. So this is here missing, right? Invalid syntax. Syntax error here. Syntax. Okay. So comma missing here. So here first error itself stopped here. Okay, so if any error comes, interpreter stops. Any error comes, interpreter stops. It won't go to next statements. Any error comes, it stops simply here. Okay, yes. Yes, yeah, any error comes, yes, interpreter stops. Okay, now let us correct this mistake here. Let us correct this mistake. Stop this mistake. Syntax error. Mistake correction is done. After correction, now run again here. Yes, what happens here? Yes, next error stopped. This is next error, right? Line number 12. Line number 12 here stopped. Okay, showing error and stopping here. error at some 12th line and stopped. So it's not checking all the lines here. Interpreter not checking all the lines here. If any error comes, simply stopping there only. If any error comes, simply stopping. That means shows only one error. Actually, there are three errors, but showing only one error, right? Okay. Yes. Now this is error. Now again this error, right? Only one error showing here. So that means if any error comes, stops. Any error comes, simply stops here. Not 12th line. So this is here missing. This bracket missing. This bracket missing. Save and exit. Now again run it here. See, I'm using up arrow key. You get the previous commands up arrow key. Yes, it will maintain history. Command prompt will maintain history. Up arrow key, down arrow key. We can use like this. See, every time typing, time taken here instead of this, use up arrow key. Previous command, same previous command, right? Up arrow key, previous command. Okay. Yes, up arrow key. So I see this now 16th line error. 16th line error. 16th line error. Okay. Now let us correct this error here. 16th line error. So that means showing only one error at a time here. Only one error. Okay. That correction is done. Save and exit. Okay. Now run it. Yes. Got the output finally. Right. Okay. So interpreter checks the program line by line. Checking first line. If it is correct, executes. Next line correct, executes. Next line something wrong, stops. Something wrong, stops. Something wrong, stops here. So this is interpreter. Yes. Suppose compiler. How compile is working? Let us say about compiler also. How compile is working? Yes, about compiler. Yes, about the compiler. Yes, how compile is working here? Compiler. Yes, how compile is working here? So compiler, for this I'm taking C program. I'm taking C program. C program. Okay. Yes. Test.c. Some test.c program. Okay. Yes, compiler. Some C program taking here. Suppose some C program. Yes, 1 second. Compiler. I'm taking C program. C program. Let us take some C program. Here, this is Turbo C. C programming purpose. C programming. Turbo C IDE. Here, C program. See this A equal to 10. Same program in C language. A equal to 10, B equal to 20. So B equal to 20 here. Yes, int C. Int C declared here. Next, CLR here. C equal to A plus B. So adding two numbers. Okay. Yes, next. So C equal to A minus B. Subtraction. Yes, multiplication. Okay, right? Yes. 1 second. Let me see what this is. See, this is C program. Mathematical operations. A equal to 10. B equal to 20. Yes, int C. C equal to A plus B. Addition. So addition. Next, C equal to A minus B. Subtraction. Subtraction. C equal to A into B. Multiplication. Then, yeah, this is C program. Complete C program. Yes, compile. Compile. Yes, success. No errors. Okay, success. No errors. Error 0. 0 errors. Press any key. Any key. Now run the program. Run it. See this. Addition, subtraction, and multiplication. Addition 30, subtraction minus 10, multiplication 200. That's it here. So this is C program. Suppose in this C program, for example, there are some mistakes. Suppose here semicolon missing. Suppose here some bracket missing. Okay. Suppose here some comma missing. Okay. Yes, comma missing. Suppose here some bracket missing. Okay. Yes, here semicolon missing. There are some missing statements. No, saved. Now let us compile. Yes, compilation. Now compile option. Compile. Enter key now compiling. See errors, right? Totally 6 errors. See errors. Totally 6 errors. Displaying all the errors from top to bottom. See press any key. Press any key. See that errors. First error. See look at the bottom. Look at the bottom. Yes. 10th statement is error. right? Next 13th line error, next 15th line error, 17th line error, next 21st line error, 27th line error, 29th line error, like this, all the errors from top to bottom, right? Yes, it's showing all the 10th line error, 13th line error, 15th line error, 17th line error, 21st line error, 27th line error, 29th line error. Yes, all the errors from top to bottom. Okay, compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. Interpreter is only one error, but compiler is all the errors from top to bottom. Okay, yes. So this is 1 second. Yes. So compiler, how compiler is working here? Compiler, how it's working compiler? See, compiler checking first statement, first line. Suppose if it is correct, if it is correct, if it is correct, even correct, it won't convert into binary. No, it won't convert into binary. Immediately it won't convert. First of all, checking all the lines. It won't convert into binary code immediately here. Checking all the lines from top to bottom. Checking first line, checking second line, suppose correct, then checking next line, suppose something wrong, it shows that error at some line here, error at some line. Next checking next line also correct, then checking next line also correct, then checking next line, something wrong here, error at some line here. Okay, next line checking, okay, next line checking, suppose something wrong, yes, it shows all the errors from top to bottom. Compiler checks the whole program from top to bottom. Okay, even correct, it won't convert into binary code immediately. First of all, compiler checks the whole code from top to bottom. So compiler checks the whole code from top to bottom. What is interpreter here? Line by only one line checking. If it is correct, immediately execution. Next line checking. If it is correct, immediately execution. Something wrong stops. Suppose any mistake stops. Interpreter shows only one error. Interpreter shows only one error. See compiler. See in case of compiler, what happens here? Yes, first line checking correct. Even correct, it won't execute. Next line checking correct. Next line. Suppose something wrong. Yes, error at some line. After next line, top to bottom. Compiler checks the whole program from top to bottom and shows all errors. Even error getting goes next line also. Next line also. Next error. See this compiler. Yes, it's showing all the errors from top to bottom, right? See all the errors. See this 10th line error, 13th line error, 15th line error, 17th line error. Okay, 21st line error, 27th line, 29th line. So compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. Now let us correct mistakes here. Yes, let us correct mistakes here. So void main function. Okay, int b is equal to 20. Semicolon missing here. Next here, CLR is here, bracket missing here. Suppose here, comma. Okay, later I'll correct that. Wait. Suppose semicolon missing. Later we'll see. Yes, now file I can save it here. Yes, overwriting. Now compile. Yes, still three more errors, right? So 3 errors done. Now 3 more errors. Okay. Now comma missing here. So next here, semicolon missing. Now save it. Saved. Yes. Now compile. Yes, errors. Still one more error. See this here. This is error. Okay. Yes. Now save it. Yes. Now compile. Recompile. Yes. Success. Okay. Program successfully completed. Okay. Program successfully completed. Okay. Yes. If no errors, what happens here? Yes. Program success. No compilation errors. Yes. No compilation errors. Suppose everything is fine. Everything is fine. If everything is fine, what is next step here? If everything is fine, next step, what is next step? Now run this. So getting output, right? So when I run this, what happens here? First of all, this whole code converts into binary format. First of all, this complete code, that source code, this called a source code. This code is a source. This is called a source code. The C program is source code. So complete this source code completely converts into binary formats. Converts into binary formats. Converts into binary format. That whole code converts into binary formats. The complete code converts into binary formats. Okay, top to bottom, all the statements converts into binary formats. So these statements from top to bottom converts into binary formats like zeros ones formats, zeros ones formats. Okay, zeros ones formats. Okay, so zeros ones format. All this code converts into binary formats. Okay, yes, zeros ones formats. So zeros ones format. All this code converts into binary format. Simply code converts into binary format and write to another file. This complete source code test.c, the C program completely converts into binary format and write into another file. Here, this file is called as exe file. Okay, test.exe file generates. Exe means executable file. So executable file ready to execute. Now this exe file given to processor. So processor taking that exe file and executes generating output simply. See, let me show that exe file also. See here. So this is program. For this program backend. Yes, C drive. Yes, turbo C installed here. Next bin. Inside of bin, yes, all programs are there. This is inside the bin, all programs. What is name of the program? Math.cpp. CPP, C language, both are same. Both are compiler based. CPP compiler using for C language also. CPP compiler is CPP means C++. C++. Both are same. So math.cpp. Math.cpp. See math.cpp. So this is math.cpp file here. 1 second, let me delete some old files here. There are some old files. Okay, so this is math.cpp. See 51851 AM, right? Today this is modified. Just on today date. See this 51 2023. So Jan 50 2023 851 AM, right? Just now it's modified. Okay, edit. See this is your program. This is program, right? This is program. Backend. You can see that program. Okay, now compiles, success. Now when I try to run, what happens? See, just observe backend here. When I try to run here, something here happens here. When I run this, see that math, some new file create 8:55 AM application. What is it? 51 5th Jan 2023 8:55 AM. Yes, this is what exe file. Application means exe file. Let us check extension. Yes, properties. Go to properties. See that .exe file, right? Math.exe file created. So math.exe file created. Exe file created and executing. Yes, now executed. Exe created and executed. So when I run this, yes, exe file created and executed simply here. Okay, run it here. Yes, addition 30, subtraction minus 10, multiplication 200. So what happens? Exe file generates. So exe file generated. Test.exe file got it, that executed it. Now tell me guys, what is the difference you observed between interpreter and compiler? Tell me. Of course, I'll compare these two. I'll explain. So what you observed. So from this explanation, practically, yes, interpreter and compiler practically explained. Tell me the difference. What's the difference you observed here? What's the difference you observed? 1 second, just a minute. Okay. So what's the difference observed from this expression? So interpreter is line by line. Okay. Yes, compile its whole program at a time. Next, any other difference observed? Any other difference observed? See in this page explanation. This page and this page, what's the difference? Yeah, exe file, right? Here is exe file, right? Here exe file. In compiler, yes, exe file generating. Yes, interpreter, no exe file. See this Python scripting, CLS, dir, see test.py, that Python script executing directly. It's executing directly, right? The script executing directly. Test.py, the script executing directly. Script executing directly. But what happens in case of compiler at the back end? Exe file generating. That exe file generating and exe file executing, right? So this is main difference. Exe file is a main difference. So compiler generates exe file. Compiler generates exe file. Interpreter does not generate. Interpreter does not generate. Let us see differences. Okay. Let me explain differences clearly. Interpreter versus compiler. The differences. The differences. Let us see about interpreter versus compiler. Yes, interpreter versus compiler. Interpreter versus compiler. Interpreter and compiler. So what's the difference? See, first difference. Interpreter, yes, it takes the code line by line. It checks the code line by line. Compiler, yes, it checks the code, whole code from top to bottom. It checks the code. It checks the code from top to bottom. From top to bottom. It checks whole program from top to bottom. From top to bottom. So first difference, right? So interpreter checking code line by line, but compiler it checks the code. Okay, it checks the code from top to bottom. Okay, yes, it checks the code from top to bottom. Okay, it checks the whole code. It checks the whole code from top to bottom. Next, even execution of line by line. Yes, it executes. Yes, executes and generating output. It executes and generates generates output line by line. Generates output line by line. Line by line. It generates output line by line. Okay, it generates output line by line. Yes, compiler. Yes, yes, whole code at a time here. Yes, it executes whole code at a time here. It executes, and generates out because of exe file. Right? It executes and generates output at a time here. It executes and generates output. It executes whole codes and generates output at a time here. Okay, at a time. It generates, it executes and generates output at a time here. At a time. Yes, it's not a line by line. At a time here. Because of exe file. Generating exe file, that exe file executing at a time, right? Not line by line. Direct that exe file executes. Right? Next interpreter. Yes, it shows only one error. Interpreter shows only one error. Interpreter shows only one error. It shows only one error. Compiler, yes, it shows all the errors from top to bottom. It shows all the errors. It shows all the errors from top to bottom. From top to bottom. Okay. Yes, interpreter. It shows only one error. But compiler, it shows all errors. It shows all errors from top to bottom. It shows all errors. So interpreter shows only one error. Compiler, it shows all errors from top to bottom. All the errors from top to bottom. Right? Yes. See, interpreter, any error comes stops, right? So it shows all the errors. But compiler top to bottom shows all the errors. Yes, main difference exe file. Interpreter. Yes, it does not generate. It does not generate exe file. It does not generate exe file. Compiler generates exe file. It generates exe file and finally executes. Compiler. Yes, interpreter. It does not generate exe file. Compiler. It generates exe file. Interpreter does not generate exe. Compiler generates exe file. Okay, right? Next, one more thing. Interpreter. See. Yes, the source code executing directly, right? Yes, Python test.py. That source code executing directly. But compiler what happens here? Exe file executes. Compiler based exe file executes. Exe file executes. Okay. Yes, it executes. It executes. It executes source code. It executes source code directly here. It executes source code directly. It executes source code directly. It executes source code directly. Compiler. Yes, it executes exe file. It executes exe file. It executes exe file. So these 2 points are main important difference here. Okay. Yes, interpreter don't have exe file concepts. It executes source code directly. Compiler, first of all, generating one exe file and executing that exe file. Okay. Yes, next difference. See, interpreter based languages are called as scripting languages. Interpreter based. So these are called as scripting languages. They're called as scripting languages. Scripting languages. Called as scripting languages. Okay, interpreter based called as scripting language. So compiler based. So these are called as programming language. They're called as programming language. Programming language. Okay. See, interpreter based. These are called as scripting language. Compiler. These are called as programming language. See, interpreter based language, scripting language. Compiler based is a programming language. Okay. Interpreter based language are scripting language. Compiler based are called as programming language. Scripting language examples. Scripting language examples. Examples. Python. Python is a best example of scripting language. Python. Next, JavaScript. JavaScript also interpreter based language. JavaScript is not a Java. JavaScript is different. Java is different. JavaScript is not a Java. Okay. JavaScript executes in browser. Okay. JavaScript executing by the browser. Browser is an interpreter for the JavaScript. Browser is an interpreter for the JavaScript. But Java program executing with JVM. JavaScript is a browser understandable language. Java is a JVM understandable language. Java different, JavaScript is different. Both are not same. So example Python, JavaScript, next Perl scripting, next PHP scripting, okay, next Linux shell scripting. They are scripting language. Next HTML also scripting language. HTML, hypertext markup language. HTML, hypertext markup language. Browser is an interpreter for the HTML. Browser is an interpreter for the HTML. Okay. Programming language examples. Examples is C and C++. Okay. Next C++. Next .NET C#. They are programming language. Okay. So these are scripting language, interpreter based here. These are programming language, compiler based. Compiler based. Okay, these are interpreter based language examples. These are compiler based language examples. Let us come to some conclusion here. Interpreter, compiler, conclusion. Exe file. Main difference exe file. Exe file. So interpreter based language don't have exe file. Simply finally conclusion here. Yes, interpreter. See interpreter based language. Interpreter based language don't have exe file. Don't have exe file. Don't have exe file. Okay. Yes, compiler based. Yes, everything is in the form of exe only here. Okay, everything is in exe file. Everything is an exe file. So exe file generating, finally getting exe file, then executing here. Finally exe format. Okay. So interpreter based language don't have exe file. Interpreter based language don't have exe file. Yes, compiler based, everything is in exe file. Fine, okay. So well and good. Yes, interpreter compile the differences cleared. Okay, now here some guys are getting some doubt. Yes, these guys are getting some doubt. See, maybe some you guys are getting some doubts. Yeah, this trainer, Mr. M.N. Rao, explaining about all of these things, interpreter, compiler, C language, C++, Python, JavaScript, many things talking, but he is not talking about Java. Yes, Java. What is Java? Now, yes, it's a question from you guys, I think. Yes, is doubt for you guys. What is Java? Is it interpreter based or compiler based? What is Java? Now we should yes come to conclusion about Java also. So what is Java? Yes, our topic is Java. So Java, is it interpreter based or compiler based? Let us come to some conclusion on Java also here. Java. So let us start Java. Now I am starting Java. Java. Is it interpreter based or compiler based? Yes, anyone idea about it? What is Java? Is it compiler based or interpreter based? So what is Java? Yes, what is Java? Okay, need to compiler based. Sagatika compiler. Okay, yeah. Swami Konda depends on both. Okay, fine. Now let us see what is exactly Java. Yeah, one second. Let me have some water. Let me have some water. Yes, what is Java? Let us see about Java. What is Java? See, so first of all, I'll explain about Java. You decide it finally here. I'll explain how Java is working. I'll explain about Java. You decide it. Okay. See, except Java. In other languages, what happens here? Other languages, except Java in other languages, what happens here? Maybe interpreter based language or compiler based language. In other language, what happens here? First of all, source code. Source code. See, this is called as source code. The C program is source code. This is your English language. That English language code is source code. Called as source code. Yeah, this is source code, C program source code. This is C program source code. It's a C program source code. It's a Java program source code. Yes, that English language code is source code. It's a source code. Okay. Yes. The source code simply converts into binary formats. Binary formats. Binary codes. But binary code given to processor. Processor taking that code generating outputs. Right? Okay. Yes, except Java in other languages. Maybe interpreter based language or compiler based language. Interpreter or compiler. Any case, just source code simply converting to binary format. Source code simply converting to binary formats. Okay, that source code simply converting to binary formats. Okay, yes, source code simply converting into binary formats. Source code converting to binary formats. Okay, yes, source code simply converting to binary format and given the processor then executing, right? Okay, so the case of except Java. Next in Java, what happens? Let us see. Java. Java, what happens here? Java, what happens? So first of all, source code converts into byte formats. Byte code. Byte code. This byte code converts into binary codes. Binary code, right? Binary code. Binary code given to processor. Binary code given to processor. Processor generating output, right? What is happening here? In Java, there is a bytecode introduced here. There is intermediate codes. So first of all, source code converts into bytecode here. That bytecode to binary code. Source code to bytecode to binary code. So between source code, binary code, there is a bytecode introduced in Java. So why this bytecode introduced in Java here? Why bytecodes? Yeah, this is to make the Java as independent platform. Bytecode. Bytecode is to make the Java as independent platform. Yes, why bytecode? It is reason to make the Java as independent platform. Yes, we'll discuss. Wait. About bytecodes and independent platform. Next coming topic, we'll discuss. Wait. Now source code converts to bytecode to binary codes. Okay. Now source code to bytecode. Yes. Let me show that practically. Also, we'll discuss. So D drive, support test folder. Yes, one second. Exit CMD command prompt. Actually, Java. Yes, every day our class expression is using Eclipse. Okay. Yes, in real time also always using Eclipse. So for understanding purpose, just this Eclipse. In Eclipse writing code and explaining. So our daily class topic is using Eclipse only here. Using Eclipse. For understanding purpose, now I'm using Notepad. For understanding purpose, I'm using Notepad. So this is Eclipse. Okay, Eclipse. Yeah, this is evening batch. Last night evening batch class. Okay. So Eclipse. Like in Eclipse writing all the code, all this. Okay, Eclipse. So the Eclipse, right? It's Eclipse code. Yes, writing code in the Eclipse. Okay. Yes, our class is completely in Eclipse only here. Daily class. Now today I'm using Notepad. For easy understanding purpose, I'm using Notepad here. Notepad. Detailed test. Detailed test. Here, writing one sample program. Yes, see this. D colon D drive. That will take D drive. D here. Yes, not test folder. D drive test. D drive test. D drive test. D drive test. Okay. Yes. So D drive and test. D drive test. Evening batch will take some time. It's next week, we're planning evening batch. Next week, planning evening batch. It will take some time. Okay. Maybe after festival. Yes, evening batch 7:30 p.m. 7:30 or 8:30. Mostly 8 o'clock. 8 o'clock after festival. After Pongal holidays, taking evening batch. Okay. Yes. So directory test. CD test. Change to test directory here. CLS. Clear the screen. The year. Yes. Now here I am writing simple Java program. Okay. Notepad. Yes. Test.java. Notepad test.java. So Notepad opens. Yes. This is writing simple Java program. Public. Yes. Class. Test class. Starting. Ending class. Next. Public. Yes. Static. Void. Main. Yes. String square brackets aux main method starting here system dot very simple program system dot how dot println system dot how dot println hello world hello world. Okay, closing main method. Save save and exit. So this is your program here. See this dot java test dot java program 9:17 a.m. So 5-1. So 5th Jan 9th. So today just now created test.java. Now we should compile it. So this is source file. Test.java is a source code. Java C is a Java compiler. Java Sim is Java compiler. Okay, test.java. Test.java is compiled. No error. No error, not DER. See Java C test.java. Now what happens here? Source code to bytecode. So see this first test.java, test.java given to Java compiler, Java C compiler, right? What's the result file? Result file is dot plus, tested dot plus, tested dot plus. Result is tested dot plus. After compilation, result is tested dot plus, test dot plus. So test.java, this is source code. Test.java is source code. So this is source code. Okay. So source code. Test.java source code given to Java C Java compiler generated one dot class. This dot class file contains bytecode. Dot class contains bytecode. It's a bytecode. So this is bytecode. So this is bytecode. This is bytecode. Bytecode. Okay. Yes. Now tested dot class file, right? So bytecode. Now this bytecode executing Java. Yes, just okay. Yes, executed. We got the hello world, right? Java means this is interpreter. This is Java interpreter. Okay, error program compilation by the Java compiler. Yes, compiled. Java C means Java compiler. Error checking by the compiler. Java C, Java compiler checking for errors. Suppose if no errors, generated dot class file means bytecode file got it. After getting bytecode file, that bytecode file executing by the Java interpreter. So Java C means Java compiler. Java means its interpreter. So this dot class file executing by Java interpreter. Dot Java file compilation by the compiler. Error checking by the compiler. Program execution by the interpreter. Dot class file executing by the interpreter. Now what happens here? This dot class file is given to Java interpreter here. Java interpreter. Java interpreter. So Java C means Java compiler. C means compiler. C means compiler. It's a Java compiler. Okay, Java compiler generating dot class file. If the dot class file given to interpreter. So interpreter. Java interpreter, right? So Java interpreter taking dot class file here and converting to binary code. It converts into binary code. That binary code given to processor, binary code given to processor generating outputs in here. It generates outputs. It generates output file here. Now what is happening here? Source code to bytecode. This part source code to bytecode. This part by the this part source code to bytecode. So this part by the Java compiler. This part by the Java compiler. Okay, this part by the Java compiler. Source code to bytecode by the Java compiler. Next bytecode. Yes, bytecode. Bytecode to binary codes. Bytecode to binary codes. Yes, binary code with Java interpreter. Java interpreter. Java interpreter. Java interpreter. Java interpreter. Java interpreter, right? So what happens here? Java, yes, errors checking by the compiler, errors checking by the compiler, errors checking by the compiler, errors checking by the compiler. Java errors checking by the compiler. Yes, if no errors, then it generates dot class file, means bytecode file. Generates dot class. It generates dot class file. Generates dot class file means bytecode file. It generates bytecodes. Okay, source code to bytecode conversion. Okay, Java errors checking by the compiler. Yes, if no errors. Yes, if don't have any errors, if no errors, then it generates dot class file means bytecode generates. Source code to bytecode by Java compiler. Okay, right? Yes. So that bytecode executing by Java interpreter. So dot class file. Okay, dot class file program execution by the interpreter. Execution. Yes, execution by the interpreter. Execution by the interpreter. Execution by the interpreter. Execution by the interpreter, right? Okay. So here errors checking by the compiler. If no errors, generating bytecodes. That bytecode execution by the interpreter. Bytecode execution by the interpreter. Okay. See. Suppose in C language, okay, what happens? Compiler generating exe file and executing. In Python script, interpreter taking and execution, right? So Python is completely interpreter here. Yes, C language completely compiler. When come to Java, no Java depend on what? Yes, is it compiler based or interpreter based? So as per this explanation, come to some conclusion. Now tell me guys, what is Java? Is it interpreter based or compiler based? So as per this explanation, what is Java? Is it interpreter based or compiler based? What is Java? Is it interpreter based or compiler based? What is Java? Yes, what is Java? Yes, Java depends on both. Java depends on both. Java, it depends on both. Java depends on both compiler as well interpreter. Compiler as well interpreter as well as interpreter, right? So this is conclusion. Okay. Yes, Java depends on both the compiler as well interpreter. Java depends on both compiler interpreter. Okay. Yes, some question for you guys. Some question. Yes, as per your understanding here. Can we create exe file in Java? That is question. Can we create exe file in Java? Yes, it's an interview question. Can we create exe file in Java? See, in this process, so first, see notepad test.java, next compilation, test.java compilation, okay, generating dot class file execute, right? In this process, have you observed any exe file, .exe file, anywhere .exe file? No exe file, right? Java don't have exe file concept. Java don't have exe file concept. Can we create exe file in Java? No. Okay, Java don't have exe file concept. Java don't have the exe file concept. There is no concept of exe files in Java here. Java don't have exe files. Suppose exe file is there, then it's OS dependent. Wherever exe file concept is, that is OS dependent. But Java is not a OS dependent. It's independent of platform. Java is independent of platform. Yes, the topic tomorrow we'll discuss. Yes, how Java made us independent of platform. Tomorrow topic. Okay. Yes, Java don't have exe file concept here. In Java everything is a dot class file. Java everything is a dot class file. Everything is a dot class file. Okay, see dot class is not exe file. Dot class file, yes, is not an exe file. Dot class file is not an exe file. Exe file different, dot class file is different here. See exe file is a binary code file. Exe file is a binary code file. Yes, it's a OS dependent. One second. Exe file is a binary code file. Yes, it's a system understandable language. Understandable language. It's a system understandable language. Exe file is a binary code. Yes, exe file is a binary code file. Yes, is a system understandable language. So when come to dot class file is a bytecode file. Dot class a bytecode file. Yes, it's a JVM understandable language. Understandable language. Okay. Yes, exe file is a binary code, zeros ones format. It's a system understandable language. It's a processor understandable language. Dot class file is a bytecode file. It's a JVM understandable language. Bytecode is a JVM understandable language. Next, one more thing here. Exe file is an OS dependent. Okay. Yes, dot class file independent of OS. Dot class file is independent of OS. Dot class file is independent of OS. So this is just Java introduction. Okay. So Java depends on both. Yes, compiled as well interpreter. Java depends on both compiled as well interpreter. See today topic. Difference between compiled interpreter, compiler. All that points explained very clearly. The points prepared in documents. You guys running notes is not necessary. This document for you only. This document for you only. Today I'll give the drive access. Today I'll give you drive access. 1 second. Yes. So this is, see, about Java. Java depends on both compiler as well interpreter. Java errors checking by the compiler. See this source code to bytecode, binary code. This is about Java. Same what we discussed. Can we create exe file in Java? No. No concept of exe file in Java. So that Java introduction. Java introduction. Okay, this document for you only. Today I'll share the drive. Just 1 second. Just a minute. Yes, today I'll give the drive access. So your drive. Let me show the drive. So this is your drive. Yes, I'm in the core Java this drive here. So for each and everything, I'm making separate drives here. Core Java, Advanced Java frameworks for different things, different drives maintaining. Still it's open. Just a minute. So this is the drive. Java 8 software, JDK software class document. So this is your running document, now current document. Okay, yes, it's there in drive here. This drive access will give you complete material. This is it's a drive with complete material. And next, yes, your recordings, daily class recordings. Yes, last 2 classes recordings. So this is recording 8 AM. Menra Java 8 recordings. That recordings. Okay. See, last 2-3 classes. Yes, 1 second. See, for our batch, yes, WhatsApp group created. One WhatsApp last 2 classes, documents, last 2 classes topic and recording shared. Recordings here in WhatsApp group, all the information shared here. Today, I'll give the drive level access. Okay, today I'll talk to online team. I'll give you drive access. So this is a WhatsApp group in our batch. For our batch WhatsApp group. Okay, here. So this is your WhatsApp group. Yes, 14 members already joined in your batch. 14 participants. Yes. So this is WhatsApp group. Yes, for communication purpose, I'm using here WhatsApp group. Yes, my WhatsApp number. This is my WhatsApp number. Yes, 8179189123. Yes. Share your details and add to group. Yes, your name. Okay. Next, your course. WhatsApp course you are attending. Course Java. Okay, next time 8 AM. Next, your Gmail request. Share this information on active group. Okay. See, minute to minute communication. Not only group communication here, even you can see individual communication also with every student, Java student. Yesterday morning communication started already. Yes, yesterday communication. Yes, Tuesday communication, all this. With every student, individual communication also there. Every minute, I'll communicate with every student. That kind of communication, no trainer will maintain that kind of communication like me, I'm sure. So every doubt, minute to minute solving doubts. Suppose if you getting any problems, any issues in Eclipse coding, when writing code in Eclipse here, any errors getting, share in the WhatsApp, I'll solve it immediately. Immediately I'll respond, I'll show the error. Just like online practice. Any errors getting, share me in WhatsApp, that errors here. Okay, share me WhatsApp, I'll solve that immediately. So you can continue your practice easily here. So this is my WhatsApp number. Please share this information. I will add to group. Yes, at your convenient time, share it. I'll add to group. Yes, that's all for today. Yes, tomorrow. Yes, same link. Same link. Same link and same time. Same link and same time. Tomorrow, same link and same time. So that's all for today. Any doubts? Yes, guys, any doubts? If no doubts, let us wind up session for today. Yes, tomorrow class. Yes, today Java introduction given. Yes, tomorrow how Java is independent platform. Tomorrow we'll discuss about Java features. How Java is independent platform. So Friday. Okay, so after discussing about these features, next Java installation and programming starts. From tomorrow, programming also starts. So after this introduction completed here. So software introduction completed, Java introduction given. Yeah, tomorrow that Java features about how Java is independent platform. Yes, portability and these concepts here. Once you finish, then going for Java installation. Java installation, Eclipse setup, this Eclipse setup and Java installation. Okay, writing programming starts. Programming starts from tomorrow. Okay. Yes, all that introductions completed. Yes, tomorrow starting Java features and Java programming. Yes, that's all for today. Yes, that's all. So thank you guys. Thank you guys. See you tomorrow. Same time, same link. Same time, same link.